The night hums with a finer order than we expected, and in that hush between auroral curtains and the breath of the solar wind, something regular taps at our instruments, a cadence not born of chance, a lattice of time threaded through the dark as if the cosmos itself were counting aloud. We name the traveler 3I Atlas, the third of its kind to fall across our measurements from another star, but names are always late arrivals. The pulses are what arrive first, striking detectors with the crisp authority of a clock that has kept faith across light years. We listen. In the radio bands, in the thin silver of optical photometry, in polarization that swivels like a well-tuned compass, the sequence holds, the numbers line up, the gaps are deliberate. And while skepticism is our first duty, awe is our second, because there is a difference between randomness trimmed into patterns by wishful thinking and patterns that survive every attempt to shake them apart. At first, we see only the obvious, a faint, fast mover on a hyperbolic path, eccentricity greater than 1, velocity exceeding the parabolic escape speed by a margin that speaks of another sun's farewell. Its coma is understated, a breath more than a plume, with spectral fingerprints hinting at complex organics frost-welded to silicates and a trace of metals that match no simple recipe from our own Kuiper belt. That would be story enough, an interstellar relic searing past the ecliptic, but layered upon that motion is the timing, a train of microsecond-sharp radio bursts separated by intervals that map onto prime ratios. A quiet flirtation with mathematics in a universe that usually prefers messier music. Telescopes confer across hemispheres. Arrays phase their dishes like a chorus turning toward a conductor. When the cadence holds through different instruments, through different ionospheric moods, through the low growl of terrestrial interference and the high rattle of cosmic background, confidence steps closer. The pulses precess with geometry. They Doppler shift as predicted. But they also do something else. They behave as if they anticipated the medium between us and them, as if dispersion had been prepaid. That notion feels dangerous, so we test it to exhaustion. Interstellar plasma smears radio signals with a predictable frequency dependence. High frequencies arrive first, low frequencies lag behind, a chorus stretched by the electron seas between stars. Pulsars do this. Fast radio bursts do this, but 3I Atlas does something stranger. Its bursts arrive already unsmeared, as though someone had applied the inverse of the interstellar medium in advance, a chirp run backward, so the path would return the signal to perfect focus at our doorstep. If nature did this, what could be the mechanism? We model crystalline matrices with piezoelectric stress from tidal flexing. The compression waves could, in theory, tune emissions across bands, compensating for dispersion by chance as a tumbling body vents along fracture lines. We test induced currents from a conductive skeleton, the way a copper loop in a changing magnetic field can build a clock from nothing but motion and the sun's breath. Perhaps the cadence is a side effect of a geologic coil. Yet every hypothesis must clear one high bar. Intentionality is what the data feel like, but nature is a master of counterfeit signatures, and our obligation is to ask it to show its receipts. As the weeks pass and the geometry evolves, the pulses tighten rather than blur when 3I Atlas skims the outskirts of the heliosphere, a counterintuitive crispness that suggests compensation for the sun's own dispersive environment. Polarization angles swing with Faraday rotation in a way that encodes the density and magnetic field along the line of sight, and the swings match the predictions so precisely that our uncertainty budget shrinks to discomfort. In optical, a faint strobing rides atop the light curve, tiny but present, a modulation that syncs with the radio cadence at high-order harmonics like a drum answering a bell. The object's rotation, deduced from subtle photometric tumbles, locks to a beat that seems to gate the emissions. Each pulse cluster aligns with a facet facing us, a geometry that could be accidental or could be by design, like louvered shutters managing light in a cathedral. We detect bandwidth hopping, a pattern that appears in one band for minutes, then vanishes and reappears in another, as if the transmitter, if transmitter is the word, We're skipping stones across the spectrum to avoid the heaviest surf. Then the anomalies pile like clouds before a front. During Earth's nightly alignments with Jupiter's magnetotail, the envelopes of the pulses bloom as though a siphon line had been thrown between 3i Atlas and the giant planet's stretched field, borrowing coherence from distant magnetism. On nights when the solar wind slackens, the jitter subsides, as if the source knew to breathe with the sun. When coronal mass ejections roar outward, the cadence slips by a fraction of a second, yet after the storm it returns to rhythm, having gained exactly the number of cycles a model would require if it had tracked the disturbance mid-flight. We check for confirmation bias. We blind the analysts. We shuffle timestamps. The patterns persist. It is here that the hypotheses fork. Some cling to geology, a lattice of exotic ices cracking with symmetrical vigor, a stress field that replays itself like a song as the body tumbles, with polarization a mere consequence of crystal orientations and anisotropic jets. Others tilt toward engineering, a lighthouse optimized for travel between stars, a timing protocol chosen because primes are the numbers that cannot be factored by a parochial mathematics, the universal hello. Even measured wonder must not outrun the data, so we anchor the story in gravitational mechanics where we can be exact. 3i Atlas threads a course that drinks momentum from the sun and pays it back to nobody, a classic hyperbolic slingshot. But the presence of Jupiter complicates the arithmetic in a way that feels like craft. The trajectory picks up a small deflection from the giant, enough to trim the object's ecliptic crossing by minutes and millions of kilometers into a corridor of cleaner radio seeing. If you were navigating by starlight and physics alone, you would make such a choice. If you were a rock blown from a nursery around another sun, you might also pass this way by chance. The difference is intent, and intent is the one parameter nature hides best. We calculate the object's osculating elements, its inclination and argument of perihelion, watch how solar tides tug at its spin state, and see a thing that behaves as if it knows how to stay readable. The phase drift of its pulses damps near closest approach, as if a governor had kicked in to keep the clock steady in the region of noisiest plasma. When we lose it, we do so in the most dramatic place, behind the sun, where radio signals are chewed by the corona and spit back as static. For 31 minutes, the pulses vanish entirely. No smear, no crumbs. In that absence, suspicion finds a purchase. Is someone choosing when we see, not merely how? We brace for embarrassment. Perhaps a terrestrial transmitter polluted our line of sight and then shut off. Perhaps our data pipeline glitched. But when the cadence returns, it does so with a precision that feels like a ruler laid across time. The count has advanced by the exact number of cycles predicted by the geometry of the arc, plus a small residual that corresponds to the integrated dispersion measure of the coronal crossing we would have calculated had we known the electron density in that corridor hour by hour. The signal seems to have kept its own ledger through a storm it knew was coming. We are left with an old unease. Either nature is staging a magic show at the edge of our models, or so, Mione, somewhere, has taken pains to be understood. All stories of the unknown grow theories like frost. The conservative ones go first, a natural relic, rich in organics, carrying internal stresses and conductive pathways that, in this rare confluence of motion and field, ring like a bell in a language we mistake for grammar. The bolder ones step into the open, a probe, not necessarily alive, not necessarily conscious in any way we would recognize, but built to be read by any mind that can do arithmetic and tune a radio. The speculative plateau stretches to stranger horizons. Perhaps the pulses are not a message at all, but a tool, a way to measure the medium it moves through by sending back well-formed test patterns. An interstellar spacecraft could make its own radar sky, charting plasma densities, magnetic curls, turbulence scales, an autonomous mission report for any civilization with ears. Then come the theories with teeth, that the structured pulses are a fail-safe handshake designed to be recognized but not decrypted, a boundary object that tells us, you can see me, while revealing nothing that could endanger the sender. In this view, the discipline of the signal is less a greeting than a protocol. Acknowledge, correlate, resist interpretation beyond your evidence. Skepticism demands we ask about coincidences, and coincidences oblige with a list that is either damning or enchanting depending on your temperament. Why do the pulse's strongest S-curve flares coincide with the hours when Earth's ionosphere is quietest over our deepest arrays, as if granting us a cleaner window? Why did the cadence's secondary harmonic bloom on the same nights that Jupiter's magnetotail, already a ribbon stretching past Earth's orbit, was modeled to sweep closest to our line of sight? Nature does not schedule for our convenience, and yet the schedule for a month felt considerate. We compute the probabilities, drown them in Monte Carlo trials, mock the data until they either surrender their miracle status or hold it with dignity. Some coincidences evaporate under scrutiny. Others hold their ground. There is a narrow human love for the idea that the universe noticed us. Wiser minds recall that selection effects carve their own illusions. But even after the sensible cautions, too much remains aligned, the phase stability improving during segments of the path where plasma noise should have worsened, the polarization handshakes arriving in sequences that look like synchronization headers in digital communications, the brief, elegant nulls that could be punctuation or could be the breaths of a geologic machine. So we turn from signs to forces because gravity does not lie. In the three-body tangle of Sun, Jupiter, and 3i Atlas, we trace energy's arithmetic. The object enters with a hyperbolic excess velocity v that sets its fate. Nothing we do will capture it. But the geometry of the approach matters. A near miss with Jupiter could have shredded the timing if the body were soft. Tidal torques should have kicked its spin into jitter, yet instead the rotation rate settles into a plateau precisely where tidal effects peak. A conductive skeleton, metallic veiche, ends through regolith, would feel induced currents as it motors through changing fields, currents that push back, that damp chaos, that turn a tumble into a measured precession. It is a plausible mechanism for a natural clock. It is also an elegant design for a stable transmitter. Use the universe's power to run your metronome. There is, too, the sun's gravitational lens beyond 400 astronomical units, where the star's mass can focus radio waves from the far side of the sky. 3i Atlas will never get there on this pass, but if the pulses are a technique, perhaps they are common among voyagers who do. Perhaps what we heard is the roadside calibration of a civilization that rides gravity's glass to speak across the dark. In the control rooms, the mood is a gentle war between restraint and imagination. We strip the audio from the pulses because humans cannot hear radio, but we like to pretend we can. And the translation reveals a music that is beautiful only because it is even. We look for message structure, checksums, repetition codes, error-correcting architectures that would show a mind protecting its words from the weather of space, and we find only the bones of such things, not the flesh. Headers without payloads, or payloads we cannot decode because the key is not mathematics alone, but shared context we do not possess. We compose reply strategies anyway. Rehearsals for an answer we will almost certainly never have the chance to send because 3i Atlas is outbound, and by the time we aim energy back along its lane, the target will have shifted by distances our transmitters cannot bridge. The exercise is not wasted. It teaches us how to think like eavesdroppers and like diplomats, how to parse the difference between a beacon and a test pattern, how to prepare instruments for a universe that may not be quiet after all. The implications are practical and philosophical in equal measure. If a natural relic can accidentally mimic a message this well, then our SETI strategies must absorb the lesson that nature may counterfeit intelligence with exquisite fidelity. We must build algorithms that can tell geology from grammar, not by their surface beauty, but by their failure modes under stress. If, conversely, the pulses are intentional, If the space between stars contains appliances built to be seen, then we need new grammars of listening, new patience, and a humility that can sit with recognition without understanding as a valid scientific outcome, not a failure. Technology will follow thought. We will want deeper arrays with longer baselines, probes with the nerve to surf Jupiter's tail and taste its field in situ, coronagraphs that can stare at the sun's edge without blinking so that the next blackout period does not rob us of the most telling minutes. We will want interstellar precursors, fast, disciplined machines that can meet the next visitor farther out before the hot breath of the inner system confuses the air. When the object fades, it does so with the dignity of a candle walking into wind. The cadence grows fainter, then at last falls below the smear of the galaxy's own hiss. We are left with a stack of drives, a forest of plots, a vocabulary slightly bigger than the one we had before. The argument continues. It will continue for years. Some will point to cryogenic fracturing as the clockmaker. Others will name intent with a whisper and then a full voice. Either way, something changed. We have learned to expect rhythm where we assumed silence. We have trained detectors to watch for compensation, to ask whether a signal that arrives perfectly corrected has inherited its grace from physics or from a mind. We have taught ourselves a new hesitation against certainty and a new comfort with wonder that does not bow out when the lights come up. And most of all, we have remembered that exploration is not merely the art of going, but the discipline of listening with enough sophistication that when the universe speaks in the smallest voice, we do not mistake it for the creak of our own doors. In the years ahead, this encounter will live less as a verdict than as a curriculum. We will build arrays that can catch the whisper of a far comet ringed with conducting salts. We will design probes that can throw their own pulses and read the world by its echo. We will fly missions that are purpose-built to dwell in magnetic tails, to ride the boundaries where order blooms from turbulence. Perhaps we will plant a patient machine on the dark side of the moon, a permanently listening ear shielded from our own noise, and perhaps it will wake us with another cadence soon enough. And if that does not come, we will listen anyway, because listening is civilization's way of telling the universe that it is capable of more than appetite, that it can meet the night with attention, which is the purest form of respect. The future will not be quieter than the past. It will be more articulate. We will become better at hearing it. If 3i Atlas was a messenger, we answered by becoming a better audience. If it was a rock with a gift for mimicry, we have nonetheless learned a language we will use again. The beauty of science is that it does not care whether the speaker aimed for poetry. It cares that the line scans, that the meter holds, that the rhyme, the return of a pattern, is not a trick of our own longing, but a fact that can stand when our theories are asleep. We are small. The interstellar distances do not stop being cruel because a handful of pulses soften them for a season. But it is an ancient truth that progress is built from instruments that amount to saying please and thank you to a universe that owes us nothing. The cadence of 3i Atlas, whatever its source, was a door ajar. Through it, we glimpse the possibility that space is not empty, but structured by information as surely as it is bent by gravity, that the routes between suns may be painted not just with dust and plasma, but with signs, tools, or songs meant to be caught by anyone who can keep time. One evening, long after the last strong detection, an engineer plays back the clean signal at a frequency that turns timing into tone. The room fills with a steady, layered chord, simple and perfect, a music that would be boring if not for what it implies. We will add that sound to our archives. We will let to travel in the minds of the students who will build the next machines, and perhaps one of them, watching another faint stranger thread our sky years from now, will recognize the same disciplined architecture, will know to turn the right dials, to coordinate the right alignments, to ask the right impertinent questions. Maybe the message, if there ever was one, is not in the pulses at all, but in what they compelled us to become, a species with the patience to separate coincidence from design, with the humility to accept uncertainty as a companion, and with the courage to let speculation and rigor walk arm in arm without one bullying the other into silence. So the night returns to its old sound, quiet, which is not silence but the aggregate murmur of distant fires. We take our place inside that choir with a little more grace. We do not decide, finally, whether the pulses were natural or made, not because we fear the answer, but because we respect the threshold where evidence ends. We invest instead in the discipline that will move that threshold, inch by inch, mission by mission. Perhaps the next interstellar traveler will carry a clearer grammar. Perhaps the one after that will carry a payload that can be read without interpretation. A picture, a proof, a recipe. Or perhaps we will be the messengers, and when we go, we will choose cadence as our gift, because time is the only universal that does not need translation. When that day comes, we will chirp our own correction against the interstellar medium. We will prepay the smear so that someone else's dawn can receive our message unmarred. And in that act, we will join a conversation we finally believe exists, because in our own skies, we once heard the faint, steady heart of Three-Eye Atlas ticking its careful way past the sun and out into everything.